Here we cover the validation of output. TrackREX has a built-in self-double programming capability. Excel can be programmable using two methods, formula or code, and is used to our advantage. The TrackREX user output is built with a sequence that relies heavily on formula. As part of edit check testing, another sequence of code is used that is heavily coded-based, as opposed formula. Specifically, TrackREX uses one special edit check called a TRX 005. This is an edit check that checks if a vendor record is out of the expected time window from exposure, as per protocol study team tolerance. This is not just an ordinary edit check. It is an ever-present edit check, one that is never switched off. To test during dummy study creation, it requires a complete, coded approach, build of sample time expectations. In order for the test case scenarios of this edit check to pass, both the formula-built user output and code-built test case build schedules need to match. As a reminder, as part of edit check testing, 100% of all theoretical schedule time points are tested for fire and are not fire cases. By default, this means 100% of all scheduled time points will also be validated during edit check TRX 005 testing. Two birds, one stone. Essentially, this is self-double programming and validation of overall programming via edit check TRX 005. Let's try and illustrate better what we mean. Initially, when building a dummy study, the TrackREX team mapped the protocol table of events and raw data variable naming into the TrackREX tool. Then the pre-built generic TrackREX program runs. Think of the arrow as a timeline. Dummy data is created, including test cases for TRX 005. Test cases need a temporary coded built mirror of the schedule because the actual user output does not yet exist. This also eliminates any test bias, since the test data has to be created before the test data itself has the query package run over it. As part of edit check testing documentation, the test cases are logged as expected to fire or not, as denoted by the green and red dots. There is a video covering edit check testing as part of the TrackREX video series. Next, the user output is created. This is built formula-based from the dummy data previously created. Following this, the edit check package is deployed over the user output. TRX 005 will fire or not fire, also denoted by the green and red dots. The created test cases should present themselves in a one-to-one relationship with the user output. A 100% pass rate for edit check TRX 005 means the double method, aka double programming, also validated the TrackREX user output. As mentioned, edit check testing documentation is available as part of dummy study creation. Clients have verifiable proof dummy studies are validated. Let's take this notion a step further and discuss probability. Does TrackREX match CRF records to vendor records by design or by chance? We will look at a study with just a single time point. Of course, the key principle of reconciliation is to match CRF attributes to that of the vendor record. Here we'll consider the CRF time point to be a pigeonhole, and the vendor record to be a pigeon. If the pigeon is unable to see, it would still enter the correct pigeonhole because one pigeonhole for one pigeon is a 1 out of 1 probability, a certainty. Now we repeat the exercise. This time for two time points. The first pigeon seeks its pigeonhole. Two pigeonholes for two pigeons means there is a 1 out of 2 probability the first pigeon enters the correct hole. This again leaves the remaining one pigeonhole for one pigeon, so 1 out of 1 probability. Mathematically speaking, 2 times 1 equals 2. So there was a 1 out of 2 probability of pigeons to pigeonholes matching just by chance alone. We can demonstrate this in none other than Excel itself. Here we have 2 CRF time points and 2 vendor record time points. We have a bar chart. One bar is the theoretical, or mathematical, probability. And here we have a macro that will run until it has created a match on a by-chance basis. And it reiterates 200 times to adjust for the law of averages. Confused? Don't be. Just look at the bar chart. Here we can see, after the law of averages kicked in after 200 iterations, there was indeed a 1 out of 2 probability of a 1-to-1 match on any single attempt. Easy so far. We can repeat this now for 3 time points. The mathematics gets a little more complicated. But we can see 3 times 2 times 1 is 6. So in this case, there would be a 1 out of 6 probability of 3 pigeons matching 3 pigeonholes purely by chance. We can see this play out again in Excel. And again, this time with 4 time points. The probability is now 1 out of 24. The more time points, the lower the probability. And, again, in Excel. A typical TrackREX dummy study can have around 3,328 time points, or pigeonholes, with the same number of pigeons. And that's an awful lot of numbers. As powerful as Excel can be, it stopped computing the probability here. Would anyone dare calculate this? The idea that TrackREX pulls together 2 distinct data sources and aligns by chance is nonsensical. 2 distinct data sources align by design. It even goes a step further by validating itself when testing edit check TRX 005. I'm sorry, but I don't have a head for numbers. Can you explain how this is foolproof another way? Let's follow the path of one single vendor record, such as a PK sample. Now we follow the journey of a single vendor record as it is processed in TrackREX. Imagine the ball is a vendor sample. What's to stop it falling into the big void below? Firstly, we have the validated schedule framework just covered in previous slides. All scheduled samples have a CRF home. Next, we have edit checks. Finally, the TrackREX program ensures that all samples are accounted for. With all that said, other external variables can impact the quality of TrackREX outputs. So, what factors may impact the validated schedule framework? Communication. The TrackREX team not being informed of a new schedule. Vendor data being erroneous or not as per DTA. Raw CRF reports are bugged or have an unexpected change of formatting. These are all factors outside of the TrackREX system. The frequent refresh nature of TrackREX means it is more likely issues with other systems are discovered early. Let's follow the sample's journey. Whether the validated schedule framework has been impacted or not, we move down to the edit checks. At this level, unusual firing of edit checks may be an indicator something is wrong with data sources. The final level is where all samples are accounted for. The TrackREX program ensures that any sample in vendor data finds itself in the user output. So even while external factors are being addressed or corrected, it means that affected samples will be present in the user output as unscheduled samples and always brought to the end user's attention. At no point can a sample drop off into the void. Is the system foolproof? With multiple layers of validated processes and steps, we believe the system is as watertight as it can be. Don't forget that as part of both the dummy study creations and the real-world data TrackREX refreshes, that validation files are provided. It provides a summary of raw data that was fed into the TrackREX program. It lists the raw data, then how the raw data was converted to become TrackREX readable in format. Derived data which lists specific effective attributes based on the date of a record, such as effective protocol, as well as stipulating if a record was destined for the report or not, and, if so, what row is the record associated with in the user output. In effect, this lists the journey an item of data went on as the TrackREX program ran, whilst each item of data can always be referenced back to the source system, such as EDC or vendor transfers. Thank you for watching. Should you have any questions over TrackREX validation, please do not hesitate to contact us.